Hello boys and girls, so in this video we are going to check the answer for the Mastering Kirchoff Rules worksheet. Okay, so for each of the problem below we are going to write the Kirchoff equations. Then by using the scientific calculator we are going to determine the respective unknown current, resistance R, or the EMF that required in the questions. So we start with question 1. So question 1, we need to find the value of current I. So we are given the junctions. So we can apply Kirchoff first rules, the junctions rules. The summations of current flow into the junction must equal to the current that flow out of the junctions. So we have the current that flow into the junctions is 5 ampere, and the current that flow out from the junctions is 2 ampere plus 1 ampere plus the current I. So when we solve it, we can determine the value of current I. So that the current I will be 2 ampere. Then boys and girls, we proceed to question 2. Question 2, we need to find the value of the current. So we are given a circuit loop, and in this circuit loop we do not have any junctions, so we cannot apply the junction first rule in order to calculate the current. So we are going to apply the Kirchoff second rules, the loops rules, in order to determine the value of current. So in order to apply the Kirchoff second rules, we need to draw the direction of EMF first. So we draw the direction of EMF for each of the battery. So the directions of EMF must always run from terminal negative to terminal positive. So this is the direction of EMF for 6 volt, 3 volts. This is the direction of EMF, and this is the direction of EMF for 9 volt. Okay, then to apply the Kirchoff second rules, we have to specify how we are going to travel in the circuit loop. So we going to travel in the circuit loop clockwise. So I draw the direction how I'm going to travel in the circuit loop. I'm going to travel it clockwise, in clockwise directions. So we apply Kirchoff second rules, summation of EMF equal to summation IR. So let us consider all the EMF that we exist. Let us consider. So first class, so boys and girls, let us consider all the summations of EMF that exist in the circuit loop. So we compare the direction of EMF with the directions of we travel in the loop. So for the 6 volt battery, we find out that the directions of EMF is opposite to the direction of the loop. So we have a negative sign for the 6 volt battery, and then we compare the direction of battery 9 volt with the direction of the loops. So it's in opposite directions. So we give a negative sign for the 9 volt battery, and then we move on to the battery 3 volts. So we find out that the directions is also, this time the directions is same as the directions of the loop. So we give it a positive sign for the 3 volt battery. Then we have done with all the EMF in the circuit. Then we'll move on to another side whereby we will consider the product of current with the resistance. So if you notice that the current that flow in the circuit is I, and the question already marked the direction of current for us. So the direction of current is flowing clockwise in the circuit loop. So if we compare the direction of current with the direction of the loop, is the same. So the current will be having a positive sign, and this current will pass through the 3 ohm resistor, 4 ohm resistor, 1 ohm resistor, and also 2 ohm resistor. So we have 3 times I plus 4 times I plus 2I. So we have get the equations for the Kirchoff second rules. Then we solve the questions. We will get the current will be negative 1.2 ampere. Okay, then we move on to question 3. So question 3, we are given a circuit loop, and then we want to find the value of EMF. Okay, we want to find what is the value of this EMF battery. So once again, in this circuit loop, we do not have any junctions, so we cannot apply junctions rules. So we move on straight to the Kirchoff second rules, loops rules. So I'm going to apply loops rules. So once again, I'm going to draw the direction of EMF for all the battery that exists in the circuit loop. So for the 12-volt battery, so this is the direction of the EMF, and this is the direction of the unknown EMF that we want to determine. And then the current that flow in the circuit is marked as 0.4 ampere, whereby the current will flow anti-clockwise in the circuit. So specify the direction how you are going to travel to move inside the circuit loop. So we assume we are going to taking the loop anti-clockwise. So I draw the directions. I'm going to travel in the loop anti-clockwise. So now I'm going to write down the Kirchoff second rules equations. The summation of EMF that exists in the circuit loop must always equal to the summation of product current and resistance. So consider the EMF in the circuit loop. So compare the direction of EMF 12 volt with the direction of the loop. The direction is the same, so we have positive 12 volt. And then for the unknown EMF that we want to determine, we find out that the direction of the EMF is opposite to the loop. So the EMF is given a negative sign, so we have negative EMF, then equal to the product of current with the resistance in the loop. So the directions of current is same as the direction we travel in the loop, so the direction of current will be positive. So we have current 0.4, whereby it passed through the 1 ohm resistor. So we have 0.4 multiplied 1 plus the same current will pass through the 8 ohm resistor. So we have plus 0.4 multiplied 8, and then the current also will pass through the 1 ohm resistor. So plus with 0.4 multiplied 1 ohm resistor. So then we solve it using calculator. We will get the unknown EMF is 8 volts. Alright. Okay, then now we proceed to another question, question 4, whereby we have two loops. We are given two circuit loops. So we want to find the value of current I1, I2, and I3. So class, if you refer to the circuit, you will find out that if you consider this junction, for example, junction B, you will find out that basically we have three circuit paths. I repeat, basically we have three circuit paths for this question, whereby this is the first circuit path, and the current flow in this first circuit path is I1. Then we have another circuit path, this one, and the current that flow along this second circuit path is I2. We denote by I2. And then we have the third circuit path, this one, whereby the current that flowing through the third circuit path is I3. Okay, so when you color each of the circuit path with different color, you can see very obviously the current I1 will flow through the 3 ohm resistor and also the 2 ohm resistor here. But for the 1 ohm resistor, the current that flow through the 1 ohm resistor is I2, and I3 will flow through the 3 ohm resistor and also the 5 ohm resistor at the bottom here. Okay, so after we have identified the current that flow through each of the resistor, and then we draw the direction of EMF. So this is the direction of EMF drawn for the 5 volt battery and also the 2 volt battery. We draw the EMF. Again, I remind you, the direction of EMF must always run from negative to positive of the battery. Alright, and then now we will first try to apply the Kirchoff first rule. So we consider the junctions. We consider junction B. So when we consider junction B, the current that flow into junction B must equal to the current flow out from the junctions. So we have I1 flow into the junctions, and the current that flow out of the junction will be I2 and I3. So I cannot solve the question because all the three value of current is unknown. Anyhow, we try to rearrange it so that later we can use the mode equations in calculator to solve the simultaneous equation directly. So I have I1 minus I2 minus I3 equal to 0. So I put this one as equation 1. Okay, so because we have 3 unknowns, so we have to determine another 2 equations in order to solve the question. So in order to determine another 2 equations, I'm going to apply the Kirchoff's second rules. We call it as loops rules. Boys and girls, maybe some of you might ask, teacher, we have another junction here, E, the junction E. Can I apply once again the Kirchoff first rule in order to get another equations? Actually, you will find out that there is no point for us to apply Kirchoff first rule twice, because actually we will get the same answer. For example, the summation of I in equal to summation of I out. So if we consider this junction E, so the current that flow into the junction will be I2. Then the current that flow out from, and also I3 will also flow into the junction. So plus I3. Then the current that flow out from junction E will be I1. So if we rearrange the equations, we are going to have I1 minus I2 minus I3 equal to 0. So if you notice that you will get the same equation actually, same as the one that you write out by referring to junction B. That's why it doesn't matter you write the equation first Kirchoff rule using which junction. They will give you the same equations, okay? So for junctions rules, we only can apply once at any junctions. At any junction, once only, because you will always get the same answer, the same equation, okay? So I consider the circuit loop on the left hand side. I denote it as loop 1. So I'm going to travel the loop clockwise. So the summation of EMF is equal to summation of IR. So consider the loop 1. So if we compare the EMF 5 volt, we will find out that the direction is same as the direction we travel in the loop. So we give 5 volt a positive sign. So we have 5 volt. And then we move on to another side, IR. So we find out that the current that passing through the 2 ohm resistor and 3 ohm resistor here is I1. And the direction of current I1 is same as the direction of loop. So it will be positive. So we have I1 times 3. So 3 I1 plus 2 ohm times I1. So 2 I1. 2 I1. And then we don't forget, we still have a current here, whereby this current I2, we are going to pass through the 1 ohm resistor, and the direction of current with the loop is the same, so it will be positive for the current. So I2 multiplied 1, so I have I2 here. So again, I try to simplify it, so I'm going to have 3 plus 2, so I have 5 I1 plus I2 equal to 5. So I leave it at equation 2. Then I'm going to have another equations whereby I'm going to consider the loop. Another loop on the right hand side, loop 2. Then I can assume that we're going to travel in the loop clockwise, in clockwise direction. So again, I'm going to have summation EMF equal to summation IR. So for the second loop, we have one battery here, so that we compare the direction of EMF with the direction of the loop. We find out that is in opposite directions, so we are going to have negative sign for the 2 volt battery. So I have negative 2, and then I consider the product of current and resistance. So if we refer to the loop, we will find out that I3 is same, the direction of I3 is same as the direction we travel in the loop. So I3 will be going to have a positive sign. The I3 will passing through the 3 ohm resistor, so we have 3 I3 and then 5 multiplied I3, okay? 5 multiplied I3. But then for the 1 ohm resistor, we find out that the I2, the current I2 that passing through the 1 ohm resistor now is opposite to the direction of the loop. is opposite to the direction of the loop, so we are going to have negative I2 multiplied 1. So when we write it down, we are going to have 5I3 minus I2 plus 3I3. So I solve it. 5 plus 3 will be 8I3 minus I2 equal to negative 2. So this will be our third equations. So class, we already have the 3 equations. So now we are going to use the scientific calculator to solve the equations for the 3 unknowns, I1, I2 and I3. So we are going to choose the mode equations 5. Then we choose the function 2 whereby we have 3 unknown. Okay, then we put in the value. So I1, 1, then we have negative 1, then we have negative 1, then we have 0, okay, then we have the second equations, 5I1, I2, then we do not have any I3 for second equation, so 0, then 5, then we move to the third equations. The third equations, we do not have any I1, so I1 is 0, 0. Then we have I2 negative 1. Then we have I3 8. The numbers is negative 2. Okay, then we will get the answer straightforward. So the x in the calculator will represent the first unknown. So our first unknown is I1. So the current I1 is 0.811 ampere. Then we have y represent I2. So the current I2 will be 0.943 ampere. Then we have z represent the third unknown I3. So the value is negative 0.132 ampere. So just leave it as negative. The negative just telling us that the directions of the current should be opposite to the direction that indicates in the questions. Okay, so no worries with the negative sign. Okay, then we're done with question 4. Okay, class, we continue. We move on to question 5. Again, we are given a circuit network. We want to find the value of I1, I2 and I3. So again, like what I told you on the previous questions, you can identify the junctions. So you consider this junction, you will find out that there are 3 circuit paths. So this is the first circuit path, whereby the current flow through we denote by I1. So the I1 will flow through the 4 ohm resistor and 3 ohm resistor that sit on this circuit path. And then we have the second circuit path, this one, and the current flow through is denoted by I2. Anyhow, if you notice, this circuit path do not have any resistance. And then we have the third circuit path, I3. We denote the current flow through the third circuit path is I3. Then there are 2 resistors sit on this circuit path, 3 ohm and 2 ohm. So 3 ohm and 2 ohm will have current I3 passing through it. Okay, so again, first we are going to apply the junctions rules in order to get the first equations to solve the questions. So maybe we consider junctions, which junction we want to consider. Maybe we can consider this one. I denote as A, so we consider the junction here, sorry. We consider the junction here. So I find out that my I1 will flow into the junctions. Same goes for I2. It will flow into the junctions. But I3 will be flow out from the junctions. So I'm going to have I1 plus I2 equal to I3. So I shift I3 to the left hand side, so I have I1 plus I2 minus I3 equal to 0. So this one will be denoted as equation 1. Then we need to get another 2 equations in order to solve the question. So we are going to apply the Kirchoff second rules for the loop 1 on the left hand side and loop 2 on the right hand side. So we consider loop 1 first. So we are going to travel the loop, the circuit loop clockwise. So as usual, we draw the direction of EMF. So the direction of EMF for 6 volt is from negative to positive. This is the direction for EMF 6 volt. This is the direction of EMF for 8 volt. And we draw the direction of EMF for 4 volt. So this is the direction of EMF for 4 volts. Okay, the direction EMF is always from negative to positive. Okay, then we write down the Kirchoff rules. Second rule, summation EMF equal to summation IR. So consider loop 1. Consider loop 1. So we have 2 batteries. So consider the 8 volt. We find out that the direction of EMF and the direction of the loop is opposite. So we give a negative sign for 8 volt. And then we consider the 6 volt, the direction of EMF also opposite to the direction we travel in the loop. So we give a negative sign also for 6 volt battery. And then we move to the right hand side. We have product of current with resistance. So the current I1 are going to passing through the 4 ohm resistor, and the direction of current is the same. So we have positive 4 I1, and then this current I1 also passing through the 3 ohm resistor. So we are going to have I1 times 3. Okay, but then be careful, class. I remind you, be careful. Do not include I2. Do not include I2 here. Why? Because for the current I2, there is no resistance. There is no resistance. The current I2 didn't pass through any resistance. So we do not have any I2 here. So we are going to have equations 4 plus 3, 7 I1, minus 8, minus 6, we get negative 14. So we leave it at equations 2. Okay, then we consider loop 2. So class, we consider loop 2. Then for loop 2, we are going to travel anti-clockwise. So actually, it doesn't matter. You want to travel in the circuit loop, whether clockwise or anti-clockwise. So for loop 2, we try to travel in anti-clockwise directions. So we consider the EMF first. So if we compare the direction of EMF 4 volt with the direction of loop is opposite, so we have negative 4. And then we consider the direction of EMF for 8 volts. So we find out that the direction of EMF also opposite to the direction of the loop. So we get a negative sign, negative 8. Then we consider the product of current and resistance. So if we compare the direction of I3 with the direction of loop is opposite, so the current I3 are given a negative sign. So the I3 will passing through the 3 ohm resistor and 2 ohm resistor. So we have negative 3 I3, negative 2 I3. Okay, then the current I2 doesn't pass through any resistance, so no need to include the I2. No need to include the I2. Okay, so we are going to have negative 5 I3 equal to negative 12. So this one will be our third equations. So this one will be our third equations. This will be our third equations. So once again, you might pause the video and then you can solve the question using the mode equations in your calculator. So we will get I1 is negative 2 ampere, I2 is 4.4 ampere, and I3 is 2.4 ampere. Let's proceed to question 6. So we still are given a network circuit. So we want to find the value of I1, I2, and I3. So if we refer to the junction here, if we refer to this junction, so we are going to have 3 circuit paths, whereby this one will be the first circuit path, and then we denote the current that flow is I1. So the 4 ohm resistor and 3 ohm resistor that sit on this circuit path will having current I1 flowing through it. Then this will be our second circuit path, whereby the current flow along this line will be I2. Then we have this one as our third circuit path. So the current that flow in this circuit path will be I3, this one I3. So 5 ohm and 1 ohm resistor, the current that flow through is I3. Boys and girls, in order to solve this question, first we are going to apply Kirchoff's first rule, the junctions rule. So let's say I consider the junction here. then I'll find out that my I1 will flow into the junctions, okay? My I1 will flow through into the junction, okay? So, same go for I3. If I trace out the current I3, it will flow into the junction also. But how about I2? If I trace out the I2, so I find out that I2 will be flow out from the junction, okay? So I'm going to have I1 plus I3 equal to I2, so I rearrange the equation. So I1 minus I2 plus I3 equal to 0. So that one will be our first equations. Then in order to find the 3 unknown, we have to get another 2 equations. So we are going to apply Kirchoff's second rules. So we apply the Kirchoff's second rules for the loop 1, the loop on the left hand side first. So we try to travel in the loop clockwise, in the clockwise directions. So before we write down the equations, we draw the direction of the EMF. So this is the direction of EMF for 10 volts. This is the direction of EMF for 3 volt, and this is the direction of EMF for 7 volt. Okay, so we consider loop 1. So compare the direction of EMF with the directions of the loop, how we travel in the loop. So for the 10 volt, we find out that the directions of EMF and the loop is the same, so it will be positive 10. And then if we compare the direction of EMF 3 volt with the directions of loop, it will be opposite. So it will be negative sign for 3 volts, so we have negative 3, then equal to, so the current I1, if we compare the direction of current I1 with the direction of loop, is the same, so the current I1 will be positive. So this current I1 passing through 4 ohm resistor, so we have 4 I1, and then current I1 will also passing through 3 ohm resistor, so we have positive 3 I1. And then we have I2. I2 is passing through the 2 ohm resistor. If we compare the direction of I2 with the direction of loop, is the same. So I2 will be also positive. We give a positive sign. So I2 multiplied the resistance is 2 ohm. So we have positive 2 I2. So we simplify it. So we have 4 plus 3, 7 I1 plus 2 I2. 10 minus 3, we get 7. So this will be our second equations. Then we are going to consider the loop 2 on the right hand side. Then we are going to travel in the loop, in the closed loop, clockwise, in the clockwise directions. So total EMF equal to total IR. So we compare. The direction of EMF 7 volt is opposite to the directions of loop. Okay, it's opposite to the direction of loop, so we give it a negative sign, negative 7. And then we compare the direction of 3 volt with the direction of loop. The direction of loop is in the same direction, so we have positive 3, and then equal to the product of current and resistance. So if we're checking the I3 will going to passing through 5 ohm and 1 ohm resistor. So the direction of current I3 and the direction of loop is opposite. So I3 will have a negative sign. So we have negative I3 times 5. The resistance is 5. And then the 1 ohm resistor, so negative I3 because the resistance is 1. And then we have I2. If we compare the direction of I2 with the directions of loop 2, the directions is opposite, so I2 will be negative. So I2 passing through 2 ohm resistor, so we have negative 2 I2. Then we solve it, we will get negative 2 I2 minus 6 I3 equal to negative 7 plus 3 is negative 4. So this one will be our third equations. Then you might pause the video, take out your scientific calculator using the mode equations. Then we are going to solve the questions. So So we get X is represent I1 is 0.706 ampere. Y represent I2, 1.029 ampere. Z represent the third unknown, I3, so it's 0.324 ampere. Then we solve question 6. Okay, let us practice again using question 7. Find the value of I1, I2, and I3. So, as usual, identify the current that flow through in each of the circuit path, and then draw the direction of EMF for each of the battery. Then we choose how we are going to travel in the loop. So we still have two loops here, loop 1 and loop 2. So I'm going to travel the loop 1 in clockwise direction, loop 2 also in clockwise direction. So first we identify a junction. So we are going to apply our junction rules first. So let's say I consider the junction here. So I'm going to find out that I3 is flow out from the junction. So this is I3, and our I2 also is flow out from the junction, but our I1 will be flow into the junction. So we have I3 plus I2 equal to I1. So rearrange I1 minus I2 minus I3 will equal to 0. So this one will be our first equations. Then we apply Kirchoff's second rules for our loop 1. We travel clockwise in the loop. So as usual, we are going to compare the direction of EMF with the direction of the loop. So for the 9-volt battery, we find out that the directions is opposite. So 9 would have a negative sign, and then equal to the product of current and resistance. So I3 are going to passing through the 8 ohm resistor. So the direction of I3 is same as the direction of the loop. So I3 is positive. So we have 8I3, positive 8I3. And then the current that passing through the 18 ohm resistor is I2. So we compare the direction of current I2 with the direction of the loop. We find out that it's opposite, so I2 will have a negative sign. So negative I2 multiply 18 ohms. So this will be our second equations. Then we consider the second loop, loop 2. We are going to travel clockwise. So compare the direction of EMF 6 volt with the direction of the loop. We find out that they are in the same direction. So we have positive 6, and then current I1 are going to passing through the 12 ohm resistor. The direction of current I1 and the loop is the same. So we have positive I1 multiplied 12 ohm. Then we have current I2 passing through 18 ohm. The direction of current I2 is the same as the direction of the loop. So we have positive 18 I2. So this is our third equation. So now again, you are going to solve it using the mode equations in your calculator. So we get the I1 is negative 0.131 ampere, I2 0.342 ampere, I3 negative 0.355 ampere. So boys and girls, we proceed to question 8. So for question 8A, we need to calculate the current I1, I2, and I3 that flow in each of the circuit path. And then question B, what does it imply if the calculated current is negative? Okay, so we solve question A first. We try to determine I1, I2 and I3. So again, we are going to apply the Kirchoff first rule and second rule. So we refer to junction A, refer to junction A here. So we are going to apply Kirchoff first rule, the junction rule, summation I in equal to I out. So we can see very obviously the current that flow into the junction is I2. The current I1 and I3 is flow out from the junction. So we have I2 equal to I1 plus I3. So rearrange it back. So we have I1 minus I2 plus I3 equal to 0. So that one will be our first equations. Then we are going to apply Kirchoff's second rules for the upper loop and also the lower bottom loop. So we denote the upper loop as L1, loop 1. So we are going to travel in the loop clockwise. For loop 2, we also are going to travel it in clockwise direction. So summation EMF equal to summation IR. So draw the direction of the EMF for each of the EMF. So this is the direction of EMF for 6 volt. This is the direction of EMF for 12 volt. So when we write the equations, we have to consider the sign conventions. So for the EMF 6 volt, we refer to loop 1. For the EMF 6 volt, if we compare the direction of EMF with the direction of loop 1, we travel in loop 1. The direction is the same, so the voltage will be positive 6. And then if we compare the direction of current I3 with the direction of the loop 1, we find out that the direction is the same, so I3 is positive, and these I3 are going to pass through 4 ohm resistor. So we have 4I3. And then for the 2 ohm resistor, the current that flow along this circuit path is I2. So if we compare the direction of I2 with the direction of loop 1, we find out that the direction is the same. So we have positive I2 multiplied with the resistor value is 2 ohms. So we have 2I2. So this will be our second equations. Then we consider the second loop at the bottom. So again, we are going to travel in the loop in clockwise direction. So compare the direction of EMF 12 volt. The direction of EMF 12 volt with the direction of loop is the same. So we have positive 12. And then if we compare the direction of 6 volt, EMF 6 volt with the direction of loop 2, we travel in loop 2. The direction is opposite. So we have negative 6. Then equal to the product of current and resistance. So for I1, if we compare I1 with the direction of the loop, we find out that the direction is opposite, so I1 should be negative. If we compare the direction of I2 with the loop, is also opposite, so I2 also should be negative. So these I2 are passing through the 2 ohm resistor, so we have negative 2I2. And for I1 is passing through 1 ohm resistor and also 2 ohm resistor, so we have negative 2I1 minus I1. Okay, because the value of resistance is 1, so 1 multiplied anything, you will still get the same thing, so negative I1. So 12 minus 6, you get 6. Then we have negative 3I1 minus 2I2, so equal to 3. So now we already have the 3 equations. So again, you can take out your calculator. You might pause the video and you can key in the value to calculate the value for I1, I2 and I3. So you will get current I1 is negative 846 ampere. Current I2 is negative 0.231 ampere. Current I3 is 1.615 ampere. So question B. So for question B, what does it imply if the calculated current is negative? So we find out that for I1 and I2, the answer is negative. For what actually means by the negative value of the current we obtained? So actually it's telling us that the actual direction of current flow is opposite to that shown in the circuit. So if we refer to the current I1. So the current I1 that's shown in the circuit is flow out from the junction, but then when we get negative, it means that suppose the current I1 should flow into the junction. Okay, the actual direction of the current flow should be opposite to that shown in the circuit. This is what we mean by the negative sign we obtain in our final answer. Alright, then we solve question 8. So boys and girls, let's check answer for question 9. So we still need to calculate current I1, I2 and I3. Okay, so we are going to draw the direction of EMF for each of the battery that exists in the circuit network, and then we choose the direction how we are going to travel in the loop 1 and also loop 2. So we are going to travel loop 1 in clockwise direction and also loop 2 in clockwise directions. Then we can see very obviously when we color out the circuit path, we will find out that current I1 are going to passing through 8 ohm resistor, I2 is passing through the 4 ohm resistor, and then for I3 are going to passing through the 6 ohm resistor. So first we apply Kirchoff first rule at junction P. So refer to junction P, we can see that I1 are going to flow into the junction and I2 is flow into the junction also, and I3 if we trace out according to the direction of arrowhead, this arrowhead, we will find out that actually I3 is flow out from the junction. Okay, flow out from the junction. So we have I1 plus I2 equal to I3. Rearrange, we have I1 plus I2 minus I3 equal to 0. So that put that one as equation 1. Then we are going to apply Kirchoff's second rule, summation EMF equal to summation IR. So we apply for the left hand side, loop 1 first. We travel loop 1 in clockwise direction. So compare the direction of the battery with the loop. So if we compare the direction of battery EMF 18 volt with the direction of loop 1, we find out that the direction is opposite. So we have negative 18. Same go for the EMF 12 volt. If we compare the direction of EMF with the direction of the loop, is opposite. So we have negative 12 equal to the product of current and resistance. So if we compare the direction of I2 with the direction of loop 1, the directions is opposite, so we are going to have negative I2. This I2 is flowing through 4 ohm resistor, that's why we have negative 4 I2. And then we have current I1 also flowing in this loop, so the direction of current I1 and the loop is the same, so it will be positive I1. This I1 is passing through the 8 ohm resistor, so we have positive 8 I1. So negative 18, negative 12, we get negative 30, so we have negative 30 equal to 8 I1 minus 4 I2. That one will be our second equations. Then we get another equation using the second loop on our right hand side. So we are going to travel loop 2 in clockwise direction. So if we compare the direction of EMF 18 volt with the directions of loop 2, the direction is the same, so it will be positive 18. And then if we compare the EMF 2 volt, the direction of EMF 2 volt with the directions of loop 2, we find out that the directions is opposite, so we are going to have negative 2 for EMF 2 volt. Then equal to the product of current with resistance. So if you compare the current I3, the direction of current I3 with the loop is the same, so we are going to have positive I3. These I3 are going to flow through the 6 ohm resistor, so we have 6 multiplied I3. Then we have current I2. If we compare current I2 with the direction we travel in loop 2, the direction is the same, so I2 will be positive. And this I2 is passing through the 4 ohm resistor, so we have positive 4 I2. So we have 18 minus 2 will be 16. Then we have equal to 4 I2 plus 6 I3. So this one will be our third equations. So we already get the 3 equations. Then again, we are going to solve it simultaneously using the mode equations in our calculator. So you will get the first unknown, I1 is negative 2.269 ampere. Second unknown represent I2, so it will be 2.96 ampere. The third unknown represent I3, 0.692 ampere. Then we solve question 9. You might pause the video to attempt question 10, 11 and 12 in the worksheet. Then we will check the answer after this. Okay, let's check the answer for question 10. So we need to calculate the current that flow through the 8 ohm resistor and B, the potential difference between point A and C. We denote by VAC. Alright, so class, for these questions, so since the question already gives us the direction of the loop, so we're taking the loop anti-clockwise. So we assume the current that flow through in the loop will be current I. So there are only one current flow in the loop because we do not have any junction here. So we assume the current flow is I and the current is flow anti-clockwise. So we are going to apply the Kirchoff second rules. So summation EMF equal to summation IR. So we draw the direction of the EMF of the battery, 6 volt. This is the direction of EMF for 6 volt, and this is the direction of EMF for 10 volt. And these two batteries have internal resistance. 6 volt have an internal resistance of 1 ohm, 10 volt have an internal resistance of 2 ohm. So compare the direction of EMF with the direction we travel in the loop. So I highlight this is the direction we travel in the loop. This is the direction we are going to travel in the loop, whereby we are going to travel in anti-clockwise directions. So when we compare it with the direction of the EMF, 6 volt, we find out that the direction is the same. So we have positive 6. Same go for the direction of EMF, 10 volt with the direction of the loop is the same. So we have positive 10. Then equal to, the current will flow through the internal resistance 1 ohm. So we have I multiplied 1. Then the current flow through the 8 ohm resistor. So we have I multiplied 8. And then we have the current flow through the internal resistance 2 ohm. So we have I multiplied 2. And then the current will passing through the 9 ohm resistor. So we have plus I9 multiplied 9, and then the current will again passing through the 12 ohm resistor here. So we have I multiplied 12. The I will be positive because the direction of current flow with the direction of the loop is the same. Then we solve the question, we will get the current is 0.5 ampere. I hope you get the same answer. Alright. Then question B, we want to find the potential difference between point A and C. So I highlight it. So we are just going to consider the circuit path in between point A and C. So I redraw the diagram. So in order to find the potential difference between point A and B, so I'll just consider the circuit path in between point A and B. So I consider this one. So we are going to have 6 volt EMF in between point A and C with internal resistance 1 ohm. And then just now we already determined the current. The current that flow is 0.5 ampere. So let's say I assume I'm going to travel from point A towards point C. So this is the direction of loop. Not loop here. I'm going to direction of we travel from point A to point C. So the potential difference between point A and point C, VAC, actually will be the summation of EMF in between the 2 points minus the summation of product current and resistance in between the 2 points. So if we travel in the loop from if we travel along the circuit path from A to C, we will find out that the direction of we travel with the direction of the loop is opposite, so we have -6 volt, and then the direction of we travel also opposite to the direction of current, so we have minus 0.5. okay, it's not that clear here. minus 0.5 multiplied the internal resistance is 1 ohm, so minus will become positive, so if you solve the question you will get -5.5 volt. Then boys and girls, maybe some of you might wondering, can I consider this circuit path in order to find the potential difference between point A and C? So actually yes, we can consider this circuit path as long as it's between point A and C. Okay, so if we consider this circuit path, let's say I still travel from A to point C. Okay, I draw the direction I travel. So now I travel from point A towards point C using this circuit path. So I still have potential difference AC is the summation of EMF minus summation of IR. So the EMF in between this circuit path, in between point A and C, will be the 10 volt. And then if we compare the direction of the EMF 10 volt with the direction of the loop is the same, so we have positive 10, then minus with the current multiplied all the resistance that we have in between this circuit path. So the current is 0.5 ampere, and if you compare the direction of current with direction we travel from A to B along this circuit path, the direction is the same, so we have positive 0.5. Then we are going to multiply this value with all the resistance that sit in this circuit path. So we are going to have 8 ohm, then the internal resistance 2 ohm, and 9 ohm plus 12 ohm. Okay, so if we solve it, we still can get the potential difference is -5.5 volt. So it doesn't matter whether you want to consider this circuit path or the longer circuit path here, as long as it's between point A and point C. Alright, let's check your answer for question 11. So question A, we want to determine current I1, I2 and I3 that flow in each of the circuit path here, and B, the potential difference across P and Q, between point P and point Q. So class, we assume I2 is flow into the junction Q. Because the question didn't draw the direction of I2 for us, so we just simply put the direction. So we assume I2 is flow into junction Q. So refer to junction Q. So we apply our Kirchoff first rule, summation I in equal to summation I out. So we are going to have I1 flow into the junction, I2 flow into the junction, but I3 is flow out from junction Q. So I1 plus I2 equal to I3. So rearrange, we have I1 plus I2 minus I3 equal to 0. This will be our first equations. Then we're going to apply our Kirchoff second rule, summation EMF equal to summation IR to the loop 1 and also loop 2. So for loop 1, we are going to travel the circuit loop clockwise. So again, we are going to draw the direction of the EMF so that we can compare it with the direction of loop. So for 6 volt, we have the direction of EMF is this one, and for the 9 volt we have this one, our direction of EMF always from negative to positive. Then we can write out our Kirchoff second rules equation. So refer to loop 1, we are going to travel clockwise direction, so compare the direction of EMF with the direction of loop is the same, so we have positive 6. Then if we compare the direction of I1 with the loop also is the same, so we have positive I1. Then this I1 will passing through the 15 ohm resistor, so we have 15 I1. And then we have I2. If we compare the direction of direction of the current I2 with the direction of loop is opposite, so we have minus I2. This I2 is going to flow through the 20 ohm resistor, so we have negative 20 I2, so that one will be our second equations. Then consider the loop below, loop 2. We are going to travel in the loop clockwise also, so if we compare the direction of loop with the direction of EMF, 9 volt is the same, so we have positive 9. Then I2 is, if we compare I2 with the direction of loop 2 is the same, so it will be positive I2. This I2 flowing through the 20 ohm resistor, so we have positive 20 I2. But then for I3, in this circuit path where we have current I3, we do not have any resistance. The resistance is 0 for the circuit path here below here, so we are not going to have any I3 multiplied 0, so it will be 0 lah. So we have equation 3. Then you can take out your calculator using the mode equations, put in all the equation 1, 2 and 3, you will get the value of current I1, I2 and I3. So if you calculate correctly, you will get I1 will be 1 ampere, I2 will be 0.45 ampere, I3 will be 1.45 ampere. Okay, then question B, we want to find the potential difference across point P and Q. So if I redraw the circuit, I just focus on the circuit path between point P and Q. So we only have resistance 20 ohm, whereby our current I2 along this circuit path is 0.45 ampere. So the potential difference between point P and Q will be the summation of EMF minus summation IR. We do not have any EMF here, so the total EMF will be 0. Then minus the resistance is 20, the current is 0.45. Then if I travel from point A to point Q, the direction of current is same with the direction I travel, so it will be positive 0.45. Then we solve it, we get the potential difference will be negative 9 volt. Then we solve question 11. Okay, boys and girls, let's check the last questions. We have calculate current I3 for the circuit. So we are going to apply our junction rule first. So summation I in equal to summation I out. So for, let's say I consider the junctions. Consider the junctions here. I consider this junction. So I'm going to find out that my I3 are going to flow into the junctions. I2 is flow out from the junction. I1 also flow out from the junction. I3 will be flow into the junction. So we have I3 equal to I1 plus I2. This one I put as my first equations. Then I'm going to apply Kirchoff's second rule, summation EMF equal to summation IR. So I'm going to consider loop 1 first. I travel loop 1 anti-clockwise directions. So for the EMF, I compare the direction of EMF forward with the direction of the loop is the same, and the direction of EMF 6 volt with the direction of the loop also the same. So I have 4 plus 6. And then the current I1 have the same direction as the direction of loop, so it's positive I1. I1 will pass it through the 7 ohm resistor, so we have 7 I1. For I3 along the circuit path, current I3 we do not have any resistance, so no need to multiply with the resistance because there is no resistance along this path. Okay, so we only have 7 I1 in these equations, so we can directly solve the value for I1. So when we solve it, we get I1 is around 1.43 ampere. And now we consider our loop 2. we travel clockwise also. So if we compare the direction of 8 volt with the direction of the loop is the same, so we have positive 8. Then if we compare the EMF 4 volt, the direction is also same with the loop, so we have positive 4 volt. So the current I2 have the same direction as we travel in the loop, so it's positive I2. I2 will passing through the 5 ohm resistor, so we have positive 5 I2. So for I3, we do not have any resistance along the circuit path where the current I3 flow through. So this will be our equations for loop 2. So we can solve for the unknown I2, so we get the current I2 is 2.40 ampere. So after we get the current I1 and I2, we substitute it back to the equation 1. We substitute back to the equation 1 here. So we are going to have, we can able to calculate the I3. So we are going to have I3 equal to I1 1.43 plus I2 2.4. So we get the I3 will be 3.83 ampere. Then we done with question 12. So class, I hope by answering all the questions in this Kirchoff worksheet, you will be able to master the Kirchoff rules. Okay, so I'll end my videos here and I shall see you in next video. Thank you. Bye bye.